We'll move on to the problem number 4, in which a coil having a resistance of 7 ohm and an inductance of 31.8 millihenry is connected to 230 volt 50 hertz supply. Calculate the circuit current, phase angle, power factor and power consumed. First you have to write the given data as XL is equal to 2 pi FL. You know, first you have to find out the circuit current. How to find out the circuit current? So if you want to find out the circuit current, we should have V by Z, the voltage by impedance. So voltage is 230 volt. 230 volt is a voltage. It has been given is the 230 volt. Impedance, how to find out impedance? Impedance Z is equal to R square plus XL square, because it is a resistance and inductance combination. The circuit is resistance and inductance combination. So Z is equal to R square plus XL square. How to find out now XL? So to find out XL, we have to use XL is equal to 2 pi FL. So if you use XL is equal to 2 pi FL, you will get the value of XL. From this you can find out the value of Z. Once you find out the value of Z, you can find out the main current, the circuit current, as V by Z, 18.85 amps. The phase angle phi, so tan inverse XL by R. In the RL series circuit, we already seen that the power factor angle phi can be calculated using the formula phi is equal to tan inverse XL by R. So from this you will get 45 degree is a lagging because it is inductive circuit. So therefore phase angle phi we got for 55. Power factor is equal to cos phi, cos of 55 degree, that is 0.573 lagging. And the power consumed, so power consumed can be given as P is equal to VI cos phi. So that is 230 into 18.85 into cos phi, will get 2484.24 watts. Problem number 5. 7 amps 230 volts 50 hertz AC supply is applied to a coil of 0.06 Henry inductance and 2.5 ohm resistance connected in series and with a 6.8 microfarad capacitor. Calculate impedance, current, phase angle between current and voltage, power factor, power consumed. So you have to read the problem and you have to understand that a coil of 0.606 Henry inductance, 2.5 ohm resistance in series with 6.8 microfarad capacitor. So that means it is a RLC series circuit. So you have to remember now the derivation of RLC series circuit, what are the things that you have discussed. So you have to find out the impedance. You have to see whether current is lagging or leading. Whether current is lagging or leading, that depends upon the inductive reactance and capacitive reactance. When inductive reactance is more than the capacitive reactance, the circuit is lagging. When the capacitive reactance is more than the inductive reactance, then the circuit is leading. So to find out that, first you have to find out XL and XC. So XL is equal to 2 pi FL, 2 pi FL, L inductance has been given. So we can find out 18.84 ohms. XC 1 by 2 pi FC, the capacitor value has been given. We can find out XC as 468 ohms. Then Z is equal to R square plus XC minus XL whole square. Why? Because XC is greater than XL, so that I can write the impedance as square root of R square plus XC minus XL whole square. Like that we can find out the impedance as 449.2 ohms. So once you find out Z, we can find out the current. I is equal to V by Z. V is equal to 230 volt. The applied voltage has been given 230 volt by Z, that just now we calculated. We'll get current as 0.512 amps. Phi is equal to tan inverse XC minus XL by R. So since XC is greater than XL, so we can write phi is equal to, is the power factor angle phi. In RLC series circuit, you can write tan inverse XC minus XL by R. So that will get 89.7 degree leading because the circuit is capacitive. So power factor cos phi, because phi we found out, from that we can find out cos phi. Phase angle between current and voltage is 89.7 degree lead. So from that we can find out the power factor. cos phi is equal to 0.0056 leading. I think 0.56. I think cos of 89.7 0.56 lead, and P is equal to Vi cos phi. From that we can get the value of power in wattage.